Okay, let's pick up where we left off with acids and bases. I think we already covered this last time, but I just want to re-review it really briefly. All right,
Yes, ma'am.
so first we need to know that any solution, even water, will always contain a mixture of hydrogen and OH ions. So even water is going to contain very, very, very tiny amounts of hydrogen and OH ions. In fact, usually the concentration of hydrogen ions is 10 to the negative seventh power. And to the negative seventh power means that we would move the decimal point 7 times to the left. So that's a very, very, very small decimal. And the same thing with the OH ions, it also is times 10 to the negative seventh power. Okay, so for acidic solutions always contain more hydrogen than they do OH. And in fact, the stronger the acid, the greater the hydrogen ion concentration. So you always need to know that acidic solutions have more hydrogen than they do OH. And again, like I mentioned last time, this doesn't mean that acidic solutions have no OH in them at all. They do, but they just don't have very much. Okay, now neutral solutions. Okay, so we need to know that neutral solutions, they have equal amounts of hydrogen and OH. Neutral solutions are equal amounts. Okay, now let's take a look at this part. Basic solutions, they contain more OH than they do hydrogen. Okay, and then the stronger the base, the greater the concentration of OH ions than there are hydrogen ions. Okay. All right, now let's take a look at some of these questions. I just want to do one as an example, possibly. Okay, so here for question 21, it says, which is true of aqueous solutions of MgOH2? Okay, so first we need to figure out if it's an acid or a base. So we need to keep in mind that we need to keep in mind how to recognize acids and bases. So MgOH2 is a base because it has a metal and an OH. Okay. Yeah, a metal and an OH. So like I said, this is a base. Then we need to remember about the properties of bases. Okay, so bases always have more OH than they do hydrogen. Okay, so that's how I know it's option one or option two. Okay, and then both acids and bases, they are always going to be considered electrolytes. And that was actually what we went over on the first day of acids and bases, is that both acids and bases are always electrolytes. Okay, now I think I'd like you to try 23, 24, and 25. But hold on, I need to erase this for 23. Yeah, okay. You can try 23, 24, 25.
For number 23, it'll be 4.
Yes, mm-hmm.
And for number 24, it would be 4.
No.
Mm,
So first we need to figure out if this is an acid or a base. Um, so what do you think it's describing? Is it which substance, like acids or bases, would have more hydrogen than hydroxide?
Okay, then it would be 1.
No. So
Oh my gosh.
let's just, like I said, let's not focus on the answer choices. I just want to discuss whether you think that that we're looking for an acid or a base. Do acids or bases have more hydrogen ions? Is that describing an acid or a base? Which one has more hydrogen in it?
The base.
No. So that's the problem, is that you would need to know properties of acids and bases. Acids have more hydrogen.
Yes,
Okay. So we're looking for an acid. How do we identify acids?
By the ions?
Like, well, both acids and bases produce ions. If we're just looking at a substance, how do we know if it's an acid or a base?
By the pH?
Well, how would we know the pH of a substance just by looking at it? That's what I'm saying. Like, if you have a substance that's just like, for example, H2CO3, how would we know if that's an acid or a base? And we're not given any other information. How could
By
how would we
by
know?
this by the CO?
Mm-mm. By the H. Basically, acids always start with an H. They have to start with an H. So because this starts with an H, that's how I know that it's an acid. So that's how we know if it's an acid or a base is by looking at, well, well, like I said, we know it's an acid because it starts with an H.
Yes, ma'am.
Okay. So in this case, for example, because we're looking for an acid, we're just looking for something that starts with an H, which is option 2.
Yes, ma'am.
Okay, you can try 25.
Number 2.
Mm-mm. So let's first identify if they're talking about an acid or a base. Do acids or bases turn blue?
Yes.
Which one though? Acids or bases?
Trying to remember acids.
Mm-mm. So bases turn blue. So right, we need to identify a base.
Bases turn blue. See.
Okay. Now we need to remember about properties of bases. So we know we're looking for a base. Let's see. Let's see, do bases have more H3O plus or do they have more OH?
They have more OH.
Okay, so good. We know it's option 3 or 4. And now about the pH. Do bases have a pH above 7 or do they have a pH below 7?
below 7.
Above 7. So acids have a pH less than 7, and bases have a pH above 7.
Yes, ma'am.
Okay. Okay. So right, must mostly just remember yeah, remembering the properties of the acids and bases. Okay, now let's take a look at calculating the pH. So we calculate the pH of a solution by taking the negative log of the hydrogen ion concentration. Okay, so let me write, you do need to memorize that equation. Now the thing is that you do not need to um, know what a log is. You don't. So a lot of people get tripped up by that, but there's actually a trick. How can I say? There's a trick that we're gonna go over. Okay, then also we do need to know that the hydrogen ion concentration does equal 10 to the negative pH. Okay, pH is therefore a measure of the concentration of hydrogen ions in a solution. Okay. Now, the cool thing is that a calculator is not required to calculate the pH if the hydrogen ion concentration is given as 1 times 10 to the negative something. If it's 1 times 10 to the negative something, then the pH is actually just equal to the exponent. So for example, 1 times 10 to the negative 2, the pH is just equal to 2. That's it. If the hydronium ion concentration is 1 times 10 to the negative 8, then the pH is just equal to 8. Okay. Now, when it's not 1 times 10 to the negative something, then you're going to need a calculator. Now, unfortunately for the TEAS, the calculator that that you're going to be given is not going to have a log button on it, but you can still use the trick that we just talked about to at least estimate what the pH would be. So for example, here we have 5.4 times 10 to the negative 8. The pH we can estimate is about 8. It's probably not going to be exactly 8, but it will be close to 8. Okay. Okay. And then so for example, hold on. Let's say, okay, so let's take a look at this one. It says, what is the pH of a solution with a hydronium ion concentration of 1 times 10 to the negative 6? Okay, so the pH, since it's 1 times 10 to the negative something, then the pH is just equal to that exponent, which is just 6. So the answer is option 3. What is the pH of a solution with a hydrogen concentration of 4.5 times 10 to the negative 8? So in this case, it's not going to be option 2. The reason why is it's only going to be option 2 if it was 1 times 10 to the negative something, but it's not. So because it's not 1 times 10 to the negative something, we're just going to use the trick to estimate. So it's going to be close to 8, but not exactly 8. So option 3 is too high. Option 1 is too low. So it's supposed to be option 4. Does it make sense?
Yes, ma'am, it does.
Okay, good. Okay, now let's look at number 28. It says the solution of which hydrogen ion concentration would have a pH of 2. So when they give you the pH, but they want the hydrogen ion concentration, you do 10 raised to the negative pH. So it's just whatever has 10 raised to the negative 2. Or I'm sorry, 1 times 10 raised to the negative 2. Okay, now let's take a look at 29. Okay, so it says, what is the hydronium ion concentration of a solution with a pH of 5.8? Okay, well, you can't really do 10 raised to the negative 5.8 as a final answer. Um, it's just going to be close to that, but not exactly. So then that's it. So it's not going to be option 1 because that would be a pH of exactly 5. It's not option 4. That's a little bit too far away because of that 8. That's the problem there. I'm not sure which one. I think probably option 3 because I think option 2 would be 6 point something. but not 5 point something. Okay. Now let's take a look at what happens when we go. Okay. Oh, trying to fix the format of this a little. Okay, so let's talk about the pH scale. So the pH scale goes from 0 to 14. And remember that it's the concentration of hydrogen slash hydronium ions. It's very important to know that each step on the pH scale is a concentration of hydrogen ions to the power of 10, or like 10 to the power of the hydrogen ion concentration. Hold on, 1, 2, 3. Oh, 9, 10. Okay, something like that. So pH of 3 means that there's 10 to the negative 3 hydrogen ions. pH of 5 means that there's 10 to the negative 5 hydrogen ions. pH of 6 means that there's 10 to the negative 6 hydrogen ions. A pH of 10 means that there's 10 to the negative 10 hydrogen ions. A pH of 13 means that there's 10 to the negative 13 hydrogen ions. So basically, right, remember that each, like the step on the pH scale, it's 10 raised to that power. So we need to understand what happens when we go up or down the pH scale, like how that's affecting the hydrogen ion concentration, or the acidity of everything. Okay, so let me write this part. When we're going down the pH scale, where the substance is becoming more acidic, less basic, the hydrogen ion concentration is increasing, and then the OH ion concentration is decreasing, and the pH is also decreasing. So let's say that a substance is going from a pH of, let's say a pH of 6 to a pH of 4. And let's say the question is asking about the substance that has a pH of 4, like how many times more acidic is it than the pH of 6? Or how many more hydrogen ions does it have? Or how many fewer OH ions does it have? The very first thing that we would need to do for any of those questions is we would need to draw a mini pH scale. Mini pH scale with those numbers on it. So I'm definitely going to do a pH of 4, a pH of 6, and then any numbers in between, which is going to be 5. Then, since we're going from 6 to 4, what we need to do is we need to remember that each step up or down the pH scale is affecting the substance by a power of 10. So, from 6 to 5, that's going to be affecting it times 10. And the same thing with going from 5 to 4 is also times 10. Well, times 10 is times 100. So there are several statements that we can make. We could say a pH of 4 is 100 times more acidic than a pH of 6. Again, where did I get that 100? From the times 10 and then times 10. A pH of 4 is 100 times less basic than the pH of 6. A pH of 4 has 100 times more hydrogen ions than a pH of 6. Notice that it's not twice as many. That's wrong. Because like I said, the pH scale is about powers of 10. Okay, now um, we could also say a pH of 4 has 100 times fewer OH ions than a pH of 6. We could also even say a pH of 4 has 1/100th as many OH ions than a pH of 6. Saying 100 times fewer is actually the same thing as saying 1/100th. Those two things mean the same thing. 100 times fewer, and then that means the same thing. Also, even 100 times less also would mean the same thing. So we could also even say that a pH of 4 is 1/100th as basic than pH 6. Okay, now let's talk about going the other direction, going up the pH scale. So in that case, we're becoming less acidic, more basic. The hydrogen ion concentration is decreasing. The OH ion concentration should be increasing, and the pH is also increasing. Maybe put it in blue so you know it goes with that one. Actually, I might put this one in red so you know that goes with that one. Okay, let's say that, wait, 8, 9, 10. Oh, I misplaced the 13. 13 should be here. Okay. All right, now let's say that we have a question that's talking about a substance going from a pH of 10 to a pH of 13. The very first thing that we should do is we should draw a mini pH scale. So we're definitely going to draw 10 and 13, and then any numbers in between, which should be 11 and 12. Okay, so this time, since we're going up the pH scale instead of down, we need to divide by 10. So 10 to 11 is dividing by 10. The reason why we're dividing by 10 is because, for example, the hydrogen ion concentration is getting smaller. And so to show that, we would divide by 10. And the same thing like with the acidity. The acidity is also getting smaller and going down. So we also have to divide by 10 for that reason too. Okay, now, um, okay, so anyway, divide by 10, divide by 10. Um, wait, I'm sorry. Divide by 10, divide by 10, divide by 10 is the same thing as dividing by 1,000 or doing multiplying by 1 over 1,000. Dividing by 1,000 and multiplying by 1 over 1,000 are the same thing. Okay, I'm going to try and write it down here. So there are several statements that we can make based off of that. We could say a pH of 13 is 1,000 times less acidic than a pH of 10. Or we could say a pH of 13 is 1/1000th as acidic as a pH of 10. Because again, when it's saying less or fewer, that's when you can use the 1 over like 100 or 1,000 or even 10,000. Just depends on how many times we move or how many times we move down the scale. A pH of 13 is 1,000 times more basic than a pH of 10. A pH of 13 has 1,000 times fewer hydrogen ions than a pH of 10. pH of 13 has 1/1000th as many hydrogen ions than a pH of 10. And a pH of 13 has 1,000 times more OH ions than a pH of 10. So 1,000 times less, 1/1000th fewer. All of those mean the same thing. So when you want to use less or fewer, you can also use the 1/1000th. Okay. I'd like for you to try 30, 31, and 32.
So for number 30, for number 30, it would be 2,
Well, is pH of 2 more acidic or more basic?
more basic.
Well, is it lower on the scale or higher, pH of 2?
It's lower on the scale.
So, are substances with a pH of less than 7 acidic or basic?
Basic,
Acidic. So, things that have a pH of less than 7 are acidic.
more acidic. For number 31, it's going to be number 3.
Mm-mm.
Going to be number 1.
So, neutral pH, what is neutral pH? What number it is?
The neutral pH is going to be 7.
Yes. So 7, 8, and 9. Basically, if you think about it, you're moving two places. And so first of all, it's going from 7 to 9.
Okay.
So it's dividing twice. So because it's dividing, it's not going to be 3 or 4. That's like multiplying.
Yes, ma'am.
Okay.
Multiplying is going to be what's going to be divided is going to be 1 over 100.
Mm-hmm.
So for number 32, it's going to be one.
Yes. Okay, perfect. Okay, let me see. Okay, let's try and find something short and that we can do in the last couple minutes. Okay, trying to find something short we can do. Okay, we could go over a little bit of knowledge of language, like formal versus informal writing. Okay, so let's take a look at the difference between formal and informal language. Okay, so the reason why formal versus informal language is important is because it can help us figure out like what's appropriate for writing. So obviously wearing a tracksuit to an interview is too informal. And then wearing a suit to the beach is it's too formal. Right. Right. In the same way, using formal or informal language is going to cause a bad impression. Okay, now we also need to know the levels of formality of English. Okay, so formal language is going to be required for textbooks, official reports, academic articles, essays, business letters, contracts, and official speeches. And then semi-formal English is used for day-to-day interactions with colleagues and teachers, popular magazines, books, interviews, and when talking with someone in authority or whom you respect. And then informal is going to be pretty much any other instance. Okay, so for formal English, we need to know when to recognize formal English. Okay, so formal English um, is going to be recognized by longer and more complex sentences. So formal language is going to have very long sentences. Here, for example, it says research has shown that learning a second language, in addition to leading to expanded career and social opportunities, can also expand the reasoning capability of the brain, although this finding is disputed by some scientists. So all of that is one huge long sentence. That's how we know that it's formal, is because it's just one big long sentence. Okay, and then it says learning another language. So less formal is going to be shorter. So for example, learning another language can improve your career and social life. And then some people also say it can make you smarter, but others disagree. Okay. Okay. Now, formal language is also going to have larger and less common words. Okay, so here, for example, the economy is currently quite robust. Nevertheless, some specialists predict an imminent recession. Okay, so we can say that less formally by just saying the economy is very strong right now, but some specialists say we'll have a recession soon. Okay, so notice that they simplify the language. So for example, instead of saying currently, it was simplified to right now. Quite was simplified to just very, and robust was simplified to strong. Nevertheless was just simplified to but. And then predict was simplified to say, and imminent is simplified to soon. Okay. All right. So yeah, the main thing is that formal language is going to have basically fancier words and less formal language is not. Okay. Okay, so here are some examples of changing less formal words into more formal words. Okay, so need was changed into um, require. So we could change that more formally to require. And then we also need to know how to do the reverse, how to go from more formal to less formal. Okay, so entire was can be simplified to whole, and then assistance could be simplified to help.